All right, so today's date is Thursday, September 26th, 9/26, 2019. Make sure your name and date are on the paper. We are talking about unknown coefficients, which is going to be either our hardest or second hardest lesson of the entire unit. And just as a heads up, no school on Friday. You guys are going to be turning this in by Monday then. You have 3 days to do this assignment, which actually works out since it's kind of a hard one. All right, objective. Who can do it? Quiet raised hand with your card. Ooh, Wyatt had a card up before Hazi. Sorry, Hazi. I know you got the last two.
Solve equations that have unknown coefficients and unknown constants.
There it is. Thank you. And I see Eamon's already updating you. Good job, Eamon. Is there, you know what the next vocab word is? Okay, so to factor. What are you undoing when I factor? How many of you, even before I ask, so before you participate, just by quiet raised hands, how many of you know what or have heard of the word factor before? Oh, awesome. Then this is going to be nice. This is going to be easier than I thought. All right, so what does it mean to factor then? To undo the what?
Would it be
Go for it, Charles.
variables or equations?
It wouldn't be either of them. It's a good guess. I'll still take the card. It's still 50 XP, even though, yeah. So I changed the system. As long as you participate, you get your XP, 50 XP regardless. Awesome. Esha, go for it.
Is it to undo the numbers?
Another good guess. I'll still take your card. So it's when I'm doing this. What does this look like? Right here.
Distribution.
Oh.
Wyatt, you can't shout out the answer.
Oh, I'm sorry. I just
The default. I know you're so excited, but it is a procedural error.
I turned in my card. I'm sorry. I just shot it.
So if you shout out answers, it is a minus HP, guys. You have to make sure that you do acquire his hand. Hey, but now that
Now I can heal myself.
No.
where is it? It's a procedure. It's like 5 HP, and then Asha is going to use protect 2 and absorb like she's going to take 3 damage.
Now I can heal.
Wait, I'll just use one. The white.
We can heal people later, but okay. So it is undoing the distribution. And if I was being very technical, I would say it's undoing any type of multiplication. Distribution is a type of multiplication, so factoring is undoing multiplication of variables, specifically, of polynomials. So we know what distribution looks like. If I do 3 times 4x minus 2, it turns into 12x minus 6. Give me a fist of 5. How well do you know how to distribute? Fist of 5. Everyone's at a 5, basically. All right, Jade is at a 5 as well? Okay, it looked like you were about to sneeze. And then if I go backwards, so let's go and make this arrow. So if I go forwards like this is called distribution, and I already have that word written down. If I go backwards, you need to have this word. It's called factor.
Wait, but why are you distributing it over the equal sign?
I'm just, so pretend that you didn't have this side. If I wanted to distribute that, it turns into 12x minus 6. If I didn't have this and I go and I turn 12x minus 6 and I factor it, it turns into 3 times the quantity of 4x minus 2.
Can I draw it over the 3?
If you want, yeah.
Hey, wouldn't these be no solutions if you put it into context?
Yeah, I guess instead of doing an equal sign, I could have put arrows. You can go one way or you can go the other way. Maybe for next year's notes, I'll change it to arrows. It shouldn't actually be I do an equal sign because, yes, they are equal to one another, but what I'm really doing is transferring one into the other form, one into the other form. It's as if I had an expression. Do I have... Yeah, okay, so can everyone see the poster in the back that has the blue, green, and yellow rectangles where it says function, expression, equation? The expression is just x squared minus 6x plus 5. There's no equal sign in an expression. An equation on the right-hand side that's in yellow, that has an equal sign where you have expressions on the left and the right. And then a function, which we haven't got to yet, is the blue, where you have f of x is equal to the expression. So if I'm just talking about an expression, just the green, and I come back to the notes, if I only had this 3 times the quantity of 4x minus 2. This is an expression. If I just had that expression and I wanted to distribute, it turns into this expression. And then if I want to factor it, it turns back into this expression. So there's not really an equation. There's really just 2 expressions that I'm talking about that can be transferred to one another. You shouldn't think of this as an equation that you have to solve. Hopefully I'm not confusing you too much, but let's go ahead and talk about how to factor out next. Go for it, Kira. A question, yes.
Why? So it's just for the example that you're distributing over the equal sign, or like when you're actually solving?
So
Because wouldn't you not distribute the 2 to 12? You only distribute when it's outside
2 to the 12. This arrow right here doesn't mean 2 goes to the 12. It just means if I go this direction from this expression to this expression, going this arrow direction, I'm doing distribution. And if I come this direction, I do factor.
So if you're going to the right, you're distributing.
Yes. Exactly. All right, so let's factor out the x. So if I have this thing, and I guess I should be putting an arrow here, because I don't want to think of this as an equation, but if I want to turn this expression, px minus 5x, and I want to factor out the x, that means I'm going to factor out the x is going to come out here. The x is going to be on the outside of the parentheses. So here's the x. If I factor out the x, I'm essentially dividing everything here by x. I'm getting rid of an x. Just like over here, if I factor out a 3, I'm dividing this by 3, it turns into 4x. Divide negative 6 by 3, it turns into negative 2. So I'm really dividing everything right here by x, which is the equivalent of just crossing it out. So what is left on the inside of the parentheses with a quiet raised hand? Looking for cards first. Eamon?
It would be p minus 5.
It is indeed p minus 5. Thank you, Eamon. That is how I factor out an x. You're going to be doing this over and over and over again today. How to factor out the variable that I'm solving for. If I'm solving for x, I'm going to have to factor out the x eventually somewhere. Is it a question? Yeah.
So all you really have to do is like take the x out and then just keep p and minus 5.
Exactly. Yep.
Let's
And that applies for every equation.
For all of today's lesson, that's exactly what you're going to be doing over and over again. Yep. Sometimes it might be py minus 5y, and you'll have to have a y out front. But it's the same procedure where you just pull it outside and leave the rest.
I feel like we did this first.
Yeah.
Cool. It's going to get harder in Algebra 1, and it's going to get really, really hard in Algebra 2, and if you're pre-calculus, it's going to go off the charts. But yes, we are going to be doing lots and lots of factoring at high school.
Feels so hopeful.
So if you understand your basic factoring, you're on the right track. By the way, I put up these posters too to help you remember sign language for Q and I. It's some good practice.
This is Q, right?
Haha. And ours for restroom, if I need to go to the restroom, it's a silent language or a sign language that is actually silent, I guess, too. And I'll just give you the thumbs up, and there's no communication. I just know that at least when I was in high school, it would be like the lesson was going awesome, and someone would be like, "Oh," and then the teacher would call and like, "Yeah, what's the answer?" I'm like, "I need to go to the bathroom." It's like, okay, like it kind of disrupted the whole lesson. So yeah, that's one of the reasons to do it. Anyway, let's do a real example. This is a real Khan Academy example that I modified, so it's going to be almost exactly what you're going to be seeing for the homework tonight. We have one homework assignment, and it's all of these. So I need to solve for x, and look at that bad guy. Oh man, tx minus p equals 3x plus 7. That looks hard. There's lots of variables happening in there. Amen, yeah.
These two equations seem pretty similar to one another in a way.
They do. Yeah, because, I mean, especially if it was a plus sign, then you could say that, oh, t could be 3 and p would be 7, and then you get the answer, right? But the thing is, there are actually an infinite number of solutions. So what we're going to do is we're going to, and this is kind of a tip that I'm going to give you off to the side. Your first step should be deal with the variable. Deal with your variable.
Which variable?
So I guess it's the variable that you need to solve for. With variable to solve. I'll add that. So I'm solving for x. So I'm going to make sure that all the x's are on the same side first. If I do that first, then usually everything else is a little bit easier. Of course, there are a bunch of ways to solve it. This will make it slightly easier if you deal with your variable that you need to solve first. And I guess deal isn't the best verb there. If I said get both variables on one side, that would be a better way. Yeah, question, Charles.
Yeah. So would you like factor out the x on both of them?
So that's exactly what we want to do. We want to do example 1. We want to factor out the x. But the problem is, in order to factor out an x, we have to have both the x's on the same side. So we can't factor out the x until we do step 1. So this is what we're going to do. We are going to move either tx or 3x to the other side by subtracting either tx or minus 3x. So it doesn't matter. I gave you both possible answers. Quiet raised hand. What are we going to do to this guy? Is it a card? Oh yeah, Kira.
You could do okay, so 3x minus 3x and then tx minus 3x and get t minus 3x.
Are you saying the quantity of t minus 3 in parentheses x, or are you saying t just minus 3x?
Like, I don't know, because you can't really take 3 from t, so it'd just be like left there.
I'll just write it out as we have it. So tx minus 3x, like you have it, and then we'll also get that minus p. Perfect. Yeah, thank you, Kira. Tx minus 3x minus p is now equal to, those guys cancel out, 7. That is a perfect first step. And it could have gone the other way. I could have subtracted tx from both sides. It doesn't really matter. The main thing is that we're dealing with our variable first. It makes it slightly easier to see what's going on. Okay, now the question here is p, this p and this p, what type of thing is that? Is that a variable or is it a constant? It's a constant.
Oh, I
Yeah,
know.
that one kind of you can shout out because it's one of those. I should have been clear, but yeah, it's a constant. I know.
It's okay. I got XP for seeing it.
This is a constant, which means it's not a variable, which means this p needs to go to the other side. So let's go ahead and what am I going to do to both sides in order to move? I can't just move p to the other side. I can't just say, okay, that's a negative p. I'm going to change that to a negative p. It doesn't work like that. What am I going to do to both sides, Larissa? Add p. So read our new equation, Larissa, after we add p to both sides.
X minus 3x equals 7. Plus p.
7 plus p. There it is. Thank you, Larissa. All right. So Larissa has put us in the perfect position to come back here to example 1. Example 1 said, oh, if you're trying to solve for x, factor out the x. And then we have only one x to deal with. And you might be questioning, well, why does it matter? Can't I just solve for it somehow? Isn't that basically the answer? No, I need x equals something. I don't want tx minus 3x equals something. I just want simple isolated x equals something. So we're going to factor it out. Who can do that for me? Quiet raised hand.
Factor out the x.
Factor out the x. Just like example 1, on the left-hand side, someone factor out the x. So we have got a bunch of good backups. I'm looking for a card if someone has it. Jade, yeah. Didn't you participate? No? Okay. Go for it.
So you do minus x to tx.
Careful. So if we factor out an x, I should just be left with an x on the outside. And what's on the inside after I factor out an x?
Oh, t minus 3.
Everyone write it down. T minus 3. And if you want to make your t slightly curly at the bottom, it makes it look like not a plus sign. So t minus 3. What's up, Charles?
Wouldn't it be like a 2x on the outside or a negative 4 on the inside? Because you're factoring out x, but there's actually 5x there.
It could be 5x, it could be 10x. We don't know what t could be, though. T could be 7, it could be 9.
But there's, so it's 3 times x minus another x.
But we don't know how many of it. So you're right in saying that. So there's negative 3x there. So what this is really saying, if I wrote this out, and I'll do this on the board. What this is really saying, minus 3x, is the same thing as saying minus x, minus x, minus x 3 times. That is the same thing as minus 3x. But how many times do I write out x here? It could be 1x, it could be 2x, it could be 3x. I don't know how many of these x's I have.
Because it's times t.
Exactly.
Okay, that makes sense.
Yeah, no, that's a good insight.
Just no.
Yeah.
I need a pencil or lead. I don't have any more lead. Thank you.
All right, so we have factored it out correctly, and we'll fill in the right-hand side as well. It hasn't changed. It's still 7 plus b. All right, and here is the key step. This step, I don't know if anyone has seen before, but let's leave it open. Does anyone know how to do this one? Or maybe thinks they know? You still get 50 XP if you want to take a shot at it.
Like like.
So we definitely don't want to now distribute, because the whole purpose was if we distribute, then we go backwards to this line.
Right.
So how do I get x by itself? There's one final step that says x equals our answer.
Oh.
Does anyone know how to do that? Wyatt?
Do you subtract 3 from t?
So we can't subtract 3 from t because they're not like terms. We don't know what t is. If we knew what t was, if t was 5, then we'd be like, oh yeah, it's 2. But good guess, you still get your 50 XP. Kira.
Do you? Wait, that doesn't work. But what I was gonna say is divide t minus 3 divided by x.
You're really, really close, but not quite. Yeah, very, very close. And I'll give you guys a hint. So it's still 50 XP to Kira. What is happening to x right now? X is being multiplied by t minus 3. I need to do the inverse operation of t minus 3. Anyone want to take another shot at it? Larissa?
So you would divide
By what?
by t, right?
Divide by everything that x is being multiplied by.
Oh.
By what then?
T minus 3.
There it is. Everyone write it down. Divide both sides by t minus 3.
I've never seen this before.
Woo, finally learning some new stuff. And then we're done. That's the answer.
Wait, what?
Really?
X.
T minus 3, that's all gone. You can scribble them all out. They're gone. X is now equal to 7 plus p, all divided by t minus 3. That is the answer. And if you want to write it out again, you can. I just ran out of room. So if you want to write it out again, I can say that x is equal to 7 plus p, all divided by t,
What the heck?
curly t, minus 3.
That actually kind of makes sense.
That does make sense.
That's kind of weird though. It might
Yeah,
it's
it is.
obviously be like why.
Yeah, why?
It's hard, but you guys can do it. I know you guys can do it. It's the same steps that you've been doing. It's just now I'm kind of throwing a little twist in there where it's not all just numbers. I'm giving you even more variables.
I don't.
So I'm going to do example 3 with you, and you're going to do example 4. So example 3 and example 4 are both the similar type of questions. Example 3 just has one extra step. What's up, Wyatt? You ready to solve it?
Yeah.
All right. Any questions on example 2 before Wyatt does the first step on example number 3? All right, Wyatt, what are we going to do to both sides? Or what's going to happen to this equation, I should say?
I know this is going to sound crazy, but I do believe that you should first distribute u into y plus j.
You are correct. Same thing with PEMDAS. You have to go down with PEMDAS, do all the orders, and once you can't go any further, then we start undoing to isolate the variable. Wyatt clearly sees that we have multiplication of parentheses. He's going to distribute. Do that for us, Wyatt.
U times y, so it would be uy plus uj equals negative 3y plus 7.
There it is. We distributed first. You ready for the next one? Or is it a question?
No, never mind.
We have distributed the u into the y and the j. If you want to do your little symbols, u into the y into the j, you can, so you can understand how to get from the first step to the second step. There's no questions. All right. Then we're on to the next step, and it's basically we've turned this into example number 2 now. It's going to be the same steps as number 2. What is the next step? I have 1 person. I have 2 people. I have 3, 4, 5. Oh, yeah, lots and lots of people. Hazi, yeah. Oh, Ulysses can be next, maybe.
Is it negative 3y plus you add negative 3y on both sides?
So add negative 3y, or do you just want to add the 3y?
Add 3y.
Okay, add 3y to both sides. And then what is our new line going to be after we add 3y to both sides, Hazi? You can look back at example 2 for reference. It's going to be very similar.
This is uy plus j.
Don't forget your thing that you just added.
Write it down. So, write that down.
uy and uj are still there. And then what do we just add?
What did we just add to that side? No.
You just got to read this one again. Plus 3y. There it is. Plus 3y. And now that's equal to 7.
Why would
Yeah.
why would you have 3? Why would you put 3y there?
So, yeah, I agree that maybe some people want to do uy plus 3y and then plus uj. It actually doesn't matter. This is the same thing. As long as you're adding all 3 of these together, you're good. As long as you have these 2 terms and you're adding the 3y, you're good. It doesn't matter the order in which you add them. It's called a commutative property addition, but you don't need to know that rule. It just means that you can switch this and this, and it's still fine. You can switch this and this, switch this and this. Everything's still fine.
I hope Tazi understands why I get ADXP.
Sure.
Well,
Question.
so you were doing uy plus 3y and you got uy. Yeah, I did.
uy plus 3y and got uy?
No, like right here. You were doing that, but you just came up with that.
Yeah, because what, I guess I should, it doesn't even where I write the 3y. I could have written plus 3y right here. While these are the like terms, I can't combine like terms because u and 3 can't be combined.
Okay, so then you just put 3y down and I.
So this 3y, yeah, just moved over here, and then I just copied this line right here. As long as these three terms are being added, then you're good.
Okay.
They get cool music.
And then Hazi, what's left on the right-hand side? I already have it written down. You just have to read. The right-hand side is. You can just read this one right here.
What is it?
7. There we go. All right. So Hazi did our second step. We need a third step now. We need to do something to both sides. We want only y's on the left-hand side. Something is not a y. Something does not belong. What does not belong, Ulysses?
So you like subtract uj from both sides?
There it is. Subtract uj. Subtract uj from both sides. And then, Ulysses, what is it going to be?
It's 7 minus uj.
On the right-hand side?
Yeah.
7 minus uj. And on the left-hand side, we're going to have
uy plus 3y.
plus 3y. There it is. So far, so good. All right. Question. Go.
So you can't really you're not really getting rid of the variables because you can't.
Not yet. Yeah.
Okay.
It takes a whole extra step. All right. Let's go with Charles.
You would just factor out the y.
How do I write that?
It would be y parentheses u plus 3 parentheses 3 equals negative uj plus 7.
Yep. So you could write negative uj plus 7, but just to be consistent, I'm going to write the same line that I had above here. So you are 100% correct. I'm just going to write it a little bit differently. Yes, thank you, Charles. All right, what is our final step? That really hard, tricky step. Kira?
You divide everything by u plus 3.
There it is. Divide everything by u plus 3. Divide everything by u plus 3. And we ran out of room, so I'm going to come and do it up here. Whoop. I like that sound effect. Scribble that guy out. We have. What is our answer, Kira? Y?
Y equals 7 over 7 minus uj over
U plus 3. There it is. And box it. All right. Give me a fist of 5 on example number 3 so far. How well do you think you can do example number 4? I see 5s, 3s, 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 2s, 3s, 4s. All right, we'll see. Go ahead and work together. Solve example 4. It is very, very similar to example number 3. Good luck.